Hi everyone. In this video, we're going to go through lesson 301, One-Step Inequalities. So when we had our live lesson on this today, Tuesday, October 25th, there were some glitches with our neuro platform. Some of you had trouble hearing. We had a little bit of a late start because of all of, those issues and us trying to work them out and problem solve together. So as promised, here is a nice clean cut recording of our lesson for today. So if you either missed it entirely because of sound issues, or you're still a little confused because there were some parts that we had to go through a little faster or didn't get quite as much time to practice with since we had those tech issues, this is for you. It'll give you a nice little opportunity to kind of go through this and make sure that you are comfortable and you understand how to solve both one-step equations and then the main focus of this lesson, one-step inequalities. All right, the first thing is to go over a few vocabulary words. So today we are solving equations and inequalities. Whether you're solving an equation or an inequality, the steps are pretty much the same. And your purpose in that, your overall goal, is to isolate that variable. And remember, isolate means you're getting something to be alone. We could even, think about COVID, when you had to quarantine, if you had to isolate, you needed to be alone in either your own house or your own part of, that structure. So when we get a variable alone on a side of the equation, it's going to look something like this, like x equals 7. So the x is alone, it's isolated, and I now know that x is equal to 7. Y is equal to -8, or it could even be flipped the other way around and say 25 is equal to z. This is what our answers are going to look like. This is what it means when your variable is isolated, when your variable is alone. The way that we accomplish this, the way that we solve a problem and get our answer to look like this, isolate that variable, is we use inverse operations. So if we break that vocab word down, inverse means opposite. So if you're doing the inverse of something, you're doing the opposite. And then our operations, the main ones we work with are addition, subtraction, multiplication, and division. Those are our primary operations. So if we look here, so addition and subtraction, those are inverses, those are opposites of each other. And multiplication and division are inverses, they're opposites of each other. And then you may get some problems that have fractions. So a fraction and a reciprocal are inverses. Let me give you an example of that. So if you had the fraction 2/3 and you're taking the reciprocal, you're taking the inverse, that's when you flip your fraction. So the reciprocal would be 3/2. So we'll get into an example and I'll further explain these vocab words. But our goal in order to solve these equations and inequalities is we're isolating the variable. And the way that we meet this goal, the math that we're going to do to get there, is by performing inverse, so opposite operations. All right, we're going to start off with solving one-step equations. These one-step equations are actually something that you learned in 6th grade. Now, because it's been a minute, we're going to review it here together, but hopefully as we go through these examples, it'll start to ring a bell. And if you didn't understand it in 6th grade, sometimes our brains just aren't ready for it yet. But now that you're older, now that you're seeing it, a different time, and you're just seeing it for the second time or the third time, maybe it will start to click and you'll be able to, get it and be a master of it this year. But if we look at our first problem here, let's really break this first one down to make sure we're all on the same page. It says x minus 7 equals 11. Now that we have an equal sign here, we have an equation. We have one thing is equal to another. We have an equal sign in equation. That's why our directions change from simplifying to solving. Since there's an equal sign, we can actually solve this problem. We can figure out what that variable means. That variable doesn't have to stay an unknown amount. We can figure out, in this case, this is what our variable x means. This is the number that our variable x represents. And the way that we can do that is to isolate that x, get that x all alone so we can know what he equals. What I like to do is I like to draw a line straight through my equation. It may not matter too much now, but it will really help next week when we kind of level up and have longer equations. It'll be a benefit then. So let's start these good habits and these good practices now to help us in the future. So when I draw that line down the equal sign, that kind of helps me separate the two sides. And I want to get this x, I'm going to make him green. I want to get that x all by itself. So what is currently in the way of the x being by itself? Well, that would be our -7, because that -7 is on the same side of the equation. We could think of it as they're in the same room. So therefore, if we have two people in the same room, you're not alone. You got a companion. So we have to get rid of that -7. When we're solving equations, the way we get rid of something, the way we move something to the other side of the equal sign is by performing those inverse operations. We're basically undoing it. And by undoing it, we can kick them to the other side. So it says a -7. What would be the inverse? What would be the opposite of subtracting 7? The opposite of subtraction is addition. We are going to add 7 to undo that to get rid of it. Because it's an equation, we're saying that both sides here are equal. We have to keep that equation balanced. Both sides are equal. So whatever we do to one side, we have to do to the other. Meaning if we're going to add 7 on this side of our equation, we have to add 7 on the other as well. So over here, that x is not a like term. Nothing really happens. So I'm just going to bring the x down. And then -7 plus 7 is 0. So because it's 0, it goes away. Bring down your equal sign. And now we need to do -11 plus 7. Well, -11 plus 7 would be -4. That actually is it. That's our answer. We accomplished our goal. We isolated our variable. See here, our x is all alone. He's all by himself right there. And another way you can know that you did it is you now know what x is. In this example, in order for this equation to be true, x is the number -4. So you can circle that and call it done. Let's try example number 2. So once again, I'm going to start with drawing a line through my equal sign to help me in the future separate my two sides. We are solving for x. We want to get x by itself. So what's currently in the way? What's keeping x from being alone? That plus 15. What's the inverse of adding 15? Subtraction. So we're going to undo that addition. We are going to subtract that 15 to get rid of it and kick them on to the other side. So over here, 15 minus 15 is 0. So that goes away and we're just left with our x. Bring down your equal sign. And now we have 37 minus 15, which would be 22. And we're done. We just figured out what x is. X is all alone. And I know that in this example, x is equal to the number 22. All right, let's come up here to number 3. Draw that line through your equal sign. Ooh, what's going on here? What's going on between that -8 and the x? What's that current operation? They're currently being multiplied. Remember, that's one of the ways we can show multiplication, because we can show multiplication with parentheses, we can show multiplication with a dot. But if we have a number and a variable being multiplied, they're usually shown by being smashed together. So this tells me that we have -8 times x. So to undo that multiplication, to get that variable by itself, we need to do the opposite of multiplication, which would be division. We are going to divide both sides by -8. So -8 divided by -8 is 1, which means we are just left with one single x. And then -32 divided by 8, a negative divided by a negative is a positive, so x is equal to +4. And we're done because we isolated x. X is by itself. All right, last but not least here, we have question number 4. We have x over 4 is equal to 3. What's currently going on here between the x and the 4? What's that operation that's being shown? They're being divided. They're being divided. Is remember, or maybe if you happened to miss this, if we think about that division symbol that we use, those two dots represent like numbers. So looky here, we have x over 4. So that division symbol just puts dots on the top and bottom instead of putting numbers. So that's why when you see something like this, it's division. All right, to get that x isolated, to get that x by itself, we have to do the inverse, the opposite of division. And what's the opposite of division? That would be multiplication. So we're going to multiply both sides of our equation by 4. When we do the inverse, when we undo something, it gets rid of it. So we're just left with an x on this side. And then 3 times 4 is 12, and we're done. X is by itself, and we know for this problem, x is equal to 12. All right, now that we reviewed one-step equations, we're going to transition into inequalities. Remember that inequalities are a mathematical expression that is saying, all right, instead of these two sides being equal, they may or may not be equal. They could be greater than, they could be less than, greater than or equal to, or less than or equal to. Those are our 4 inequality symbols. I know back when I was in elementary school, we would talk about them like an alligator or a crocodile, and it's always eating the bigger side to help you know which way, your inequality needed to face. So up until this point, the only inequalities that you've probably been exposed to are these examples right here that I circled in red, where you use an inequality symbol to compare numbers. So 10 is greater than 4, or 7 is less than 14. So you're comparing two numbers. What we're going to do today is we're going to do the ones that I'm circling here in blue, where you have it's basically an equation, just instead of an equal sign, we have an inequality there, okay? When we go and solve our next question, I'll talk about the differences in meaning between what the answer means to an inequality statement versus what the answer means to an equation. But the cool thing is the steps to solving an equation and solving an inequality are almost identical. So if you understood equations, then inequalities are going to be a breeze. If you didn't, then that just means we need more practice and you're going to see some more examples. So keep taking notes and this will hopefully help you out. All right, here we have 4 problems, but this time they are inequalities. So take note that those equal signs have been replaced with one of our inequality symbols. But at this point, that doesn't matter to me. I still got to solve this. Our way of solving an inequality is we still are trying to get the variable by itself, and we do so by performing those inverse operations. So addition and subtraction are inverses, they're opposites. Multiplication and division are inverses, they're opposites. We come over here to question number 1. I'm going to draw a line through my inequality symbol. And we have the problem r plus 12 is greater than 25. Well, we want to get that r by itself. So what's currently in the way of r being alone? That plus 12. We can undo that plus 12. We can get that plus 12 to the other side by doing the inverse. So what's the inverse of addition? Subtraction. We're going to subtract 12 from both sides. So 12 minus 12 is 0, which means we're only left with r. Bring down your inequality sign. And then what would be 25 minus 12? 13. All right, r is greater than 13 would be our answer. All right, let's take a moment to talk about what that answer means, because the steps to solving that were the same as an equation, but the meaning of our answer is different. So if we had an equation and we got the answer r equals 13, that means that r is only equal to the number 13, because r is equal to 13. That is the only value that works for that equation. That is the only answer that exists, 13. But when we have an inequality, r is greater than 13. That means that any number greater than 13 is a possible answer for that inequality. So 14 is greater than 13. You could do 20, you could do 100, you could do 1,000,000. Any number that's greater than 13 is a possible solution, is a possible answer. But of course, I'm not going to have you write all that out. It would be impossible because the numbers keep going to infinity. So that's where the inequality helps us out. It gives us something that's tangible. It gives us something that we can write out. So that's the main difference between the equations and the inequalities, is what their answer means. And tomorrow in class, on Wednesday, October 26th, you are going to learn how to graph these so we can get a visual of how it would look on a number line for you to graph the answers to inequalities. All right, now that I've explained the difference, we're just going to go forth and focus on the solving for these next 3 problems here. All right, question number 2 says x minus 4 is less than or equal to 14. So our goal in solving is to get our variable by itself so we can know what x is. And currently, what's in the way of x being by itself is a minus 4. So how do we get rid of that minus 4? We undo it. We do the inverse. So what is the inverse of subtracting 4? That would be addition. We are going to add 4 to both sides. So negative 4 plus 4, or a minus 4 plus 4, however you want to say it, is 0. We're just left with x and then bring down your inequality sign. 14 plus 4 is 18. That means x is less than or equal to 18. We are done. We solved for our variable. It's by itself. Let's look at number 3 here. 3n is less than 12. Well, we want to get that in by itself, but the 3's in the way. What's going on currently between the 3 and the n? Remember, that means multiplication. So it's 3 times n is less than 12. How do we undo that multiplication? We undo that multiplication by doing the inverse, division. We're going to divide both sides by 3. So 3 divided by 3 is 1. So we're left with one single n. Bring down your inequality sign, and 12 divided by 3 is 4. So we're all done. All right, last problem on this page, number 4 here. X over 7 is greater than or equal to 3. We want to solve for x. We want to get x by itself. So what's going on between that x and the 7? Because the 7 is in the way of the x being alone. That is division. That's showing us x is being divided by 7. How do we undo that division? Multiplication. We're going to multiply both sides by 7. When we do the inverse, when we undo something, it cancels out. So we're just left with x. Bring down your inequality sign, and 3 times 7 would be 21. And we're done. Okay, let's try one here with a fraction, because if you think back to that very first vocabulary page, we had talked about how addition and subtraction are inverses, multiplication and division are inverses, but then when we have a true fraction, not just division, like we had up here in number 4, when we have a true fraction, the inverse, the way that we can undo a fraction, is by multiplying by the reciprocal. So when we flip that fraction. So in our problem here, we have 2/3, so we have a full fraction. So 2/3 times d is less than 10. So we can undo that fraction to get our variable by itself by taking the reciprocal. So the reciprocal is when you flip that fraction. So it's going to become 3/2. So on the left here, when you're undoing something, it cancels out. So we're just left with d, and then bring down your inequality sign. But over here on the right, we need to actually do that multiplication. Remember, parentheses are one way we can show multiplication, and that's how I chose to write it in this case instead of using a dot. We have 10 times 3/2. Before we can multiply, we need to make both of these numbers fractions. How can you rewrite any number as a fraction? Put it over 1. Put it over 1. So let's rewrite this 10 as 10/1. Now, how do you actually multiply fractions? You multiply fractions by going straight across. So numerator times numerator, and then denominator times denominator. So 10 times 3 is 30, and 1 times 2 is 2. If you can simplify your fraction, do, and we can in this case. What's 30/2? What's 30 divided by 2? That would be 15. All right, nice work. Now we're going to get into the one difference when it comes to solving an inequality that you don't have to do when you solve an equation. All right, here's that new rule. When you have inequalities, there's one special rule, and that special rule is if you multiply or divide, so that's the only time this happens, is if you multiply or divide by a negative number, you must flip your inequality sign. Here's the reason for that, because the rule is great, but I know that some of you like to know the whys. So these two examples down here tell you the whys, but they're a little fuzzy, so I'll kind of work it off and talk it through with you. I'm just going to take two basic numbers. I'm not going to take an equation. I'm just going to take two basic numbers to explain this. Let's say we had the inequality 6 is less than 10. And we multiplied both sides by a negative number. So let's multiply this side by -2 and multiply this side by -2. We now have -12 is less than -20. Is that true? It's actually not, because remember with negatives, the farther away you get from 0, the less they are. So when you multiply by a negative, you're kind of like taking the opposite there. You're messing it up a little. And so therefore you have to flip the inequality to match that and get yourself a true statement. All right, let's try one more example. Let's say you had something like -10 is greater than -40. That's a true statement because -10 is closer to 0, so therefore it is greater than -40, which is farther away from 0. And we this time are going to divide by -2. We'll just keep it, simple here. So -10 divided by -2, a negative divided by a negative is a positive, and then -40 divided by -2 would give us 20. Is that a true statement there? Is 5 greater than 20? No, this one's a little easier to see. We know 5 is not greater than 20. That's why we have to flip the inequality. When you divide by that negative, you're changing things up, and you got to change up the inequality to match with it. So it really should be flipped, and now it's a true statement. 5 is less than 20. So there's the rationale. If you understand that, awesome. If you don't, and you just want to focus on the rule for right now, and the reason why can come later, that's a-okay. So that rule, remember, is when you're solving inequalities, if you multiply or divide by a negative number, you have to flip that inequality sign to keep it to be a true statement. All right, let's try these two examples here that will give us more practice with inequalities, and you can see some negatives. We might have to do a little bit of flipping of our signs. This first example, we have -1/2 x is greater than 8. So draw your line to separate the two sides, and I can see that the x is on the left, and I need to get that x by itself, but currently what's in the way is it's being multiplied by a -1/2. How do we undo those fractions? By taking the reciprocal. So it's currently being multiplied by a -1/2. So to undo that, to do the inverse, we're going to multiply by the reciprocal, meaning we're going to multiply by -2/1. When we do the inverse, when we undo something, it cancels out, so we're just left with x. But I'm not going to drop my inequality sign yet because I multiplied by a negative. And what do I have to do when I multiply by a negative? Flip that inequality sign. So it was facing I don't know if my camera's mirrored, so I apologize if this is wrong. It was a greater than sign, so we're going to flip it and make it a less than sign. Now we can do our multiplication. We have 8 times negative 2 over 1. So 8 over 1, so they're both fractions, and then we multiply straight across. 8 times negative 2 is negative 16. 1 times 1 is 1. And I can just rewrite that as x is less than negative 16. And we have our answer. We're done. So not really too different. We just got to remember that one rule. If we multiply or divide by a negative, you flip your inequality sign. Number 2 here. We have x over negative 3 is less than or equal to negative 6. What's currently going on between the x and the 3? Yeah, this time what we see here is division. So that's x divided by negative 3. How can we get rid of that negative 3? We undo the division, and we undo that division by multiplying. So we're going to multiply both sides by negative 3. When we do the inverse, it cancels out and we're left with x. Now we have our inequality sign here. Do we need to flip it? Yes, we do, because we multiplied by a negative number. We multiplied by a negative 3. So our inequality sign is going to flip around and become a greater than or equal to symbol. And then negative 6 times negative 3 would be a positive 18. And we are done. All right, that was the end of the examples. So a couple little announcements, because again, this was quick at the end of class today too, is make sure that you have done your 301 learn and practice. If you haven't done that yet and you're still confused, that's why the learn and practice is there. Remember, you have your independent lessons and your live lessons with me. Those come together to help your understanding. I'm not saying you'll always get it with those two things. Of course, that's why we have help sessions. But both of those pieces of learning are supposed to come together to really help you understand the material, because obviously you're not seeing me for a brand new math lesson every day. You see me for a brand new math lesson twice a week. And then the other 2 days are for some extra practice. So that's why that learn portion is important. And then the IXL assignment that goes along with this lesson here is QWH, solving one-step inequalities. There is a help video available for that as well. It would still be in my voice, because but if you want to watch that to see some new examples, maybe I explain things a little bit differently, you're welcome to do so. That's another resource. And then of course, remember that IXL has its own videos. That would be in a different voice. Maybe that would help. And then last but not least, if you've done your learn and practice, you've watched this video, you've watched the IXL video I made, and you're still getting the questions wrong on IXL, then take a beat, take a pause, and make sure you look at your schedule and come to the next help session and say, hey, can you help me on QWH? And maybe by having that back and forth interaction with me or one of the other teachers can help cause things to click, because sometimes we need to do it while it's being explained to really help, ingrain it in our brains. All right. Well, thank you guys. Once again, I'm sorry that technology was crazy this morning, but for those of you that hung with me, I appreciate it. And I'm glad I could at least make this video to help fill in the gaps and support a little bit. All right. You have a great rest of your day. Email me if you need anything. Bye.